Okay, welcome. I'm going to, in this video, go over the gas law questions present in test 4. So, okay. And that is my goal. Starting with number 2 on test 4. A compressed piston is held under 1,820 torr and has an internal volume of 175 mils. If after the piston expands, the pressure is 700 torr, what must the internal volume be? This is an ideal gas question that we can say PV equals nRT, but nRT is not known. But then we look at a different situation where P and V also equals the same nRT. So essentially, like when we do M1 V1 and equals M2 V2, we can say pressure 1 volume 1 equals pressure 2 volume 2. We don't have to convert as long as the units are the same. So 1820 and 175 equals 700 times V. So 1820 times 175 divided by 700 would give us 455 milliliters, or A. Moving down. Perfect, an effusion problem. What is the effusion rate of argon compared to chlorine? And I tried to spell it out for them so they didn't make a stupid error of doing monoatomic chlorine. So effusion rate. Rate of argon over rate of chlorine equals the square root of rate of chlorine, molar mass of chlorine over molar mass of argon. Now you should, by the name, be able to figure out that this will be a number greater than 1, because greater effusion means this number is going to be larger than 1. 1 means it's 100%. It's the same. So chlorine, 35.45. You double it, you get 70.9. Argon, I think it's 40-something. You'll get it close enough. Square root of 70.9 over 40. 70.9 over 40 is 1.7, but we have to square root 1.7. So it is actually 1.33. So it is 1.33 times faster at escaping from a container than chlorine would be. Skipping down. 8. What is the density of sulfur dioxide at standard temperature and pressure? STP stands for standard temperature and pressure, which is 0 degrees Celsius, which is 273 Kelvin, and 1 atmosphere. So what is the density? The density equation is pressure, density equals pressure times molar mass over RT. So we're given pressure is 1 atm. T is 273. R by definition must be 0.08206 atmosphere liters. And then molar mass, sulfur is 32. Oxygen is 16. 16 times 2 is 32. The molar mass is 64. So 64 times 1 divided by 273 divided by R gives us a density of 2.86, or B. 2.86. Now, I'm not going to ask you to do this one on the test, but what is the root mean square velocity of hydrogen? That time, I told them well in advance to know how to do this. the root mean square. The velocity is equal to the square root of 3RT over molar mass. 3 things to note. That R needs to be 8.314. Temperature needs to be in Kelvin, so 273. And molar mass needs to be in kilograms. So it's not 2, it is 0.002 kilograms per mole. Those 3 things are 3 different points that you could trip up on. And now we square root it, and we get 1,845 meters per second, or D. So even at 0 degrees, it is still trucking. Property of the light lamp now. Nope. Okay. 14. If the temperature on the morning of November 1st was 27 degrees Fahrenheit, and there was a high of 50 degrees Fahrenheit later the same day, by what pressure did the air volume change over the course of the day? This one, once again, much harder than I would expect. V1 over T1 equals V2 over T2. So we're rearranging that to be V1 over V2 equals T1 over T2. But we have to do this in Kelvin. So 27 degrees Fahrenheit minus 32 times 5 over 9 plus 273 puts us at 270 degrees Kelvin as the first temperature. 52 minus 32 times 5 over 9 plus 273 puts that as 284. 284. So if it went from 270 to 284, it decreased. Let's see. Let's see. What did I do wrong? A high of 52. 50. Temperature goes. Let's see. Temperature goes. Oh, I have to flip it. So, 0.95. So I flip it because I want to look at V2 over V1, not V1 over V2. So 1 divided by 0.95 is 105. So B. I said this one is so much harder than anything I won't ask of you on the test. That's it, because that's a weird one. Okay. 16. Which letter approximates the effect of all the van der Waals forces present within a non-ideal gas within the van der Waals gas equation? So you need to know the equation is pressure plus A n squared over V times volume minus NB equals nRT. Well, A is the attractive or repulsive effects. B is the atomic size. So those are the 2 constants. N is moles and P is pressure. So the correct answer is A. 17. 17 is the last one. Well, no. 17 and 20. We got 17 and 20. 17. Contrary to expectation, an exhale is not CO2 rich, but in an exhale with a total pressure of 99 kilopascals, contains only 4.158 kilopascals of CO2. If another 78.606 kilopascals of exhale is made of nitrogen and non-reactive gases, what is the partial pressure of the remaining oxygen? So, real life, when you exhale, you're releasing CO2. It's not super rich, but it is higher concentration than it started. So the total pressure, P total, is equal to P CO2 plus P nitrogen plus P oxygen. And if the total pressure is 99 and CO2 is 4.158, nitrogen is 78.606. The question is, what is our oxygen, which is what we're solving for. So 99 minus 4.158 minus 78.606 means you actually have another 16 kilopascals of oxygen and other non-reactive gases, of oxygen remaining. So it's even when you exhale, there's a bunch of oxygen you didn't use. There's enough oxygen that still greatly overpowers the CO2. So answer is D. Finally, number 20. The pressure of oxygen when it enters the lungs is about 150 millimeters of mercury in a breath. That is about 500 mils. If the temperature of oxygen is assumed to be 25, how many moles of oxygen actually get inhaled per breath? This is the only one in this problem set that is an ideal gas. PV equals nRT. Pressure is 150 millimeters mercury. V is 500 mils. T is 25 C. And R is going to be 0.08206. So first thing we got to do, convert everything. So add 273 to make it 298 Kelvin. Turn mils into liters, which is equal, so 500 mils is 0.5 liters. And 150 millimeters of mercury. There is, in one atmosphere, there is 760 millimeters of mercury. So 150 divided by 760 is 0.19. 197. So finally, PV over RT equals N. So I have 0.197 times 0.5 divided by R divided by 298. So how many moles? It's 0.00403. I'm guessing I rounded somewhere. If I rounded too much, so it should have been either way. 4.04 times 10 to the negative third. Answer is C. That is that equations you would be given. Would sound like you would be given your R's. You'd be given P1 V1 equals P2 V2, and V1 over T1 equals V2 over T2. PV equals nRT, your density equation, your basic Dalton's partial pressure equation, mean square velocity, effusion rate, and of course the van der Waals equation. So, and of course some conversions. So that is all we have. That's all. Those are the material that we'll cover for the test.